Well, good afternoon to you all. Matthew Bacon. Really good to see such a great turnout for this session, not least of which is because what I'm going to share with you today is all really relatively new work. I established the consultancy just over a year ago, and it was to work within the NHS with customers and the private sector to help them really understand these issues about better utilisation of space, but fundamentally it's about driving for low carbon and what the strategies are that we should aim to achieve new levels of carbon performance in the UK. But I think this work will inevitably travel abroad too, as you'll hear in a moment. And I'm going to be explaining to you some of the science that we've been developing, which promises a completely new way, as I say, of how we should go about designing and operating our facilities to achieve low carbon. Before I get into the meat of the messages that I want to bring over to you, David Pension said this morning, so it's always useful to kind of reference what was said earlier on, which is all the very high-level kind of strategic view of where we should be going within hospital planning and design. He says the priorities. We're on a journey, and I believe in this work, we really are very much on a journey. He says we need to communicate the science. And today I'm going to be very much involved in that. What is the science of a subject we've developed called occupancy analytics, and why is it of such fundamental importance to hospital planning, design and operation? And then he also says we have to measure and track progress. And if there's any of the sectors of the built environment that has a history of tracking progress, particularly in health outcomes, of course, it's the healthcare sector. But when you come actually into the built environment and we look at low carbon performance, we see that there's been a paucity of data about low carbon performance. We have very good high-level information. You can go into ENCODE, for those of you familiar with some of the standards, and you hear how a modern hospital should be performing from a carbon point of view. But it's all highly aggregated data. And some question its validity. Because they say if you're not collecting data as much as the clinicians would be doing at a much more atomic level, how do you know what you're reporting at high level actually has truth behind it? We assess the veracity of the data is the key issue. And what I've reflected on in the work that's led up to the formation of Conclude was that we have this paucity of data about what drives carbon performance in hospital facilities. And we found there's a huge gap in this data. And I reflected on how we might plug that gap. So that's fundamentally what this is about today. And it was in that work that I suddenly realised that we'd got some huge issues to manage within not just healthcare environment, but across the built environment generally, about this understanding about how buildings work and about developing an understanding of how they work, how that impacts upon how they should be planned and how they should be designed. And what we learned at BAA in the mid-90s was that designers make massive assumptions during the design process and the planners about how a facility will be used and operated, which the users have no knowledge of. And there's been a number of commentators, the Scottish Parliament building was one that I remember particularly, where the reflection upon the poor energy performance of the Scottish Parliament building was that the designers didn't know it was going to be operated like that, and those that were using the facility didn't know that it was designed to be operated like that. And a number of commentators in the UK have reflected on this, and they call it the Great Divide. The Great Divide between actually understanding all the opportunities in design and engineering systems that could be brought into the operational process, but are not communicated effectively to those that operate the facility, and those that operate the facility don't understand what kind of information it is required to inform the design process. So we get a facility that reflects best use and the way that people would like to operate the facility. And that divide leads, we believe, this is the great argument, to very poor energy performance. Now, one glaring issue that faces us all, not just within healthcare, but within commercial office environment and within airport design and other complex facilities, is that it is rare for the design team's aspiration for carbon performance to be ever matched by the actual operational outturn carbon performance. So if you look at an energy performance certificate and the aspiration behind that, which can be an EPC rating, an A or a B, and then you look at the DEC rating, it will be vastly different. And often, and particularly in many hospitals, the rating is down at an F and a G. And I've reflected on that and thought, why is it that we have this huge disparity? So why is it that we have this divide, and what should we be doing about it is the kind of fundamental question that we have been addressing. The National Audit Office has written a number of very interesting insights into the public estate, not just the hospital estate, and showed wide variations of usage, but estimating around 20% more space than is actually required. How many of you experience underutilised space? For those that you are, yeah, again, a fairly good show of hands. So I ask myself the question, why is it? When you're planning space, what are the factors that you need to understand that are going to give you a surety of outcome, that is the space that I need? We know we've got surplus space, but what are the factors that drive it? And this work that I'm going to be sharing with you really attempts to answer that issue. So what is the factors that drive that 35%, and how can we get better utilisation? And if a clinician or a service manager comes to you and says, we need more space, you should be saying why. What is the evidence that you need? And I'm going to provide you with the tools that you need to counter that argument. For those of you who are involved in estates and facilities and you're confronted with a clinician, the clinicians work in a world of data. That's what all the performance outcomes have driven them. And for those of you, I imagine here today, would recognise that. But in the built environment world, we do tend to rely upon standards, anecdotal information, formulaic rules of thumb. And it's all of this rather mishmash that actually leads to the issue that we've got. And then we have operational policies. And these are trotted out on, it sounds a bit divisive, but they really are, reused from one facility to another. But my question is, or the challenge, I guess, is, does the design team ever see the impact of this operational policy? Does it ever get the opportunity to understand these operational policies and reflect on how the design should be responding to those? And the challenge is that often these operational policies are in Word documents. And they're very difficult things for a design team to get into. And part of my thesis is that actually we have to, yes, operational policy information, if we're going to get a joining of this over this great divide between the designers and the planners, the facility deliverers, and the users, it's through that operational policy that we've got to make that connection. That's one of those bridges that we've got to build. The problem is operational policies are not in a form traditionally that you can have that divide, and I'll explain a little bit more about what I mean by that. Now, I'm going to go straight to the meat of a lot of what we're talking about, because I've talked a lot about principles and the issues, and with the nodding heads and the show of hands earlier, I can see that there's a good kind of a degree of empathy there. But what we have recently completed is a study to look at the occupancy profile of a major new hospital facility that we're working on. So this is our first major commission as the, in the business. I have a client who is inspired by this way of thinking and thinks that's absolutely, why have we never done this before kind of inspiration. So I've got a great believer in what we do. And what we set out to do was to challenge the fundamental thesis that designers have to work with their hands tied behind their backs, and planners, because they are working with health building notes that are decades old. They are working with these formulaic guidance, rules of thumb and so forth, if this, then that kind of approach. And these are standards that have been with us, I understand, for many, many years. And no one has really ever set about challenging them. That's what we're doing. We're setting about challenging those standards. And the way we've done it is to actually go back in to understand how a hospital operates. In the same way that I wanted to understand how an airport terminal operated and the processes that manage that terminal and what caused people to flow around the facility, so we approached it in the same way with this hospital. And the design team calculated through the room data sheets. We've got 3 people in this room, 20 people in that room, and so forth, and it all gets built up through the room data sheets, till you end up with an occupancy, a diversified occupancy, so they're recognising an element of rooms being empty some of the time, of 6,000 people. But what we established in our simulation model is an actual occupancy of 2,300. It's a radical difference. Now let's just understand, pick that apart, and understand the impacts of what occupancy means. It means an over-provision of ventilation and cooling systems. The internal loads in a building, the major internal loads in a building, heat loads, cooling loads, are from people and equipment. So my thesis is that if we understand what causes people to be where they are, then we can actually calculate the occupancy in the different areas of the hospital based upon the processes that are taking place. Hence the need for a simulation technology to model that. What does the research say? BISRIA, this is the Building Research, the Services Research Association, in 2006 did a study of 50 buildings across the UK. 100% of the ventilation plant and 88% of the cooling plant was overspecified. Now, the knowledge of over-specification of plant within the NHS goes back actually to the early 1990s. I actually have a report from the NHS talking about the dangers of over-specifying plant and the overcapacity of plant and what it means. And it means all the things that I've just been talking about. So we knew that. But what we didn't know was actually how to go about changing it. And today, as I say, is the work involved. So for those of you who doubt this thesis, I go back into the core of what engineers use as the basis for calculating a systems design. The Chartered Institute of Building Services Engineers have a guide called CIBSE Guide A, and there is a quote. Overestimating internal heat gains may result in oversizing a plant, leading to higher capital costs of plant, poor part load performance, and increased running costs. And yet all the data actually tells us that is consistently what happens across the estate. Now, the criteria that are used within the CIBSE Guide is actually embedded in modern software design. So all of the rules of thumb that are used are actually part of that. Now, I know that for a fact because when I was at BAA, I worked with some of the designers of the simulation technologies, the thermal simulation technologies, to better understand what information they needed in order to give us more predictable quality of airport facilities. This is John Egan's thesis at the time. We have got to have much better predictability of operation, of cost, time of delivery, and so forth. And we were trying to understand the factors that influence that. So history tells us an awful lot, but current practice still seems to ignore that. So if we come back to that point about the amount of over-provision of space, if we take 2 million square metres of space. You could say, rule of thumb, that that equates to 200,000 tonnes of carbon emissions per annum. Now, that is a big dent in the energy reduction targets that the NHS is committed to and that David was talking about this morning. E.C. Harris reported that the cost of that over-provision is 497 million per annum. That is the cost of one major acute facility a year. So the benefits of doing something different, the commercial benefits of doing that, are staring us in the face.